Good morning, grade 9 students, and welcome to another new school year. This first term, we are going to study about inertia, also known as the first law of motion. For our intentions, the competency, identify inertia as the tendency for an object to stay at rest or in motion unless acted on by an unbalanced net force. And for our objectives, by the end of the lesson, learners will be able to first define inertia, second, explain how inertia affects objects at rest and in motion, and lastly, identify real-life situations that demonstrate inertia. Think about it. Imagine you are riding on a running bus when suddenly the bus stops. What would happen to you? Your body flies forward, right? Even though you didn't want to move. This time, imagine that the bus is not running. Then, the bus suddenly accelerates. What would happen to you? Correct. Your body gets pushed backward even though you didn't want to move. And it's all because of inertia. Over 300 years ago, a genius named Sir Isaac Newton figured out the rules of how things move. He came up with 3 scientific laws, but today we will focus on the first one, the law of inertia. For our learning experience, we will be having an activity, and it's titled the Coin Drop Challenge. Our goal is to get the coin into the glass without lifting the card and without touching the coin. How do we do that? To do that, flick the edge of the card sharply with a finger. The card flies away, but the coin drops straight down into the glass with a satisfying clink. Guide questions. Why didn't the coin fly away with the card? Another question, what force eventually pulled the coin down into the glass? Now for the answer key. Why didn't the coin fly away with the card when you flick it? The answer is because of inertia. Even though the card moved, the heavy coin wanted to stay right where it was. At rest, the card slipped out from under it. And now for the second question, what force eventually pulled the coin down into the glass? Once the support, that is the card, was gone, gravity was the unbalanced force that pulled it down. The Newton's first law of motion states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Now, to make it simpler for you to understand, let's break it down into 2 parts. First, the object stays at rest. For example, a soccer ball on the grass won't move until you kick it. That means that you applied an unbalanced force on it. Second, an object stays in motion. A marble continues to roll on a smooth floor until it eventually stops because of friction. That is the unbalanced force. Now, we have a question to ponder. If there were no friction and no gravity, meaning there's no unbalanced force, what would happen to the movement of marble? Right, it would move forward forever. Now, not all objects have the same inertia. Which one is harder to move? Is it the ping pong ball or the bowling ball? So the answer is, the bowling ball is harder to move because it is heavier. So, basically, mass is a measure of inertia. If an object has more mass, it has more inertia. meaning it is harder to start moving, and when it is moving, it is harder to stop. And if an object has less mass, it has lesser inertia. It means that it is easier to move and easier to stop. This is why a bicycle is easy to stop, because it has less inertia. And a loaded truck needs a long distance to hit the brakes. The truck has massive inertia. And now for the application of inertia. Imagine a car traveling at 60 kilometers per hour. Your body inside the car is also traveling at 60 kilometers per hour. If the car hits a wall, the car stops instantly. But because of inertia, your body keeps moving at 60 kilometers per hour. Without a seatbelt, you keep moving forward until you hit the dashboard or windshield. The seatbelt provides the unbalanced force to stop your body safely. So always make sure to fasten your seatbelts whenever you're riding a car. Another application is when you are tightening the hammerhead. Why does the downward motion and sudden stop of the hammer tighten the hammerhead? When the handle hits a solid surface and stops abruptly or quickly, the heavier head continues moving downward due to its inertia, forcing it further onto the handle. Another application is a magic trick. Have you seen this trick? Why does the plates and glasses stay on the table when tablecloth was removed abruptly or quickly? The dishes and glasses have mass. Therefore, they have inertia. Now, because they are initially at rest, their tendency is to stay at rest in that exact spot. Another example, when getting ketchup, why do you move the bottle down so fast and then stop suddenly? The ketchup inside has inertia and keeps moving down, coming out of the bottle. And now, let's wrap up the Newton's first law of motion. First, inertia is the tendency of an object to resist changes in its motion. Mass is equivalent to its inertia. The heavier the object, the stronger the inertia. Unbalanced forces like friction, gravity, or applied force like push are what change motion. And now for assessment. Get ready and get your pen and papers. Let's answer the following question. Number 1. Which property of an object determines how much inertia it has? A. Volume, B. Temperature, C. Mass, D. Speed. Number 2. If you are riding a skateboard and hit a curb or a stone, what happens to your body? A. You fly forward. B. You fly backward. C. You stop instantly with the board. Or D. You float up. Number 3. According to Newton's first law, an object in motion will always stay in motion unless acted upon by A. A balanced force, B. An unbalanced force, C. Magic, D. Velocity. Number 4. Which object has the greatest inertia? A. A tennis ball, B. A bicycle, C. A school bus, or D. A cat. And for the last item, why do we need to wear seat belts? A. To look cool, B. Because the seat is slippery, C. To increase the weight of the car, or D. To stop our inertia from throwing us forward during a crash. It's time for our answer key. Check your answers. Number 1, the correct answer is C. The measurement of inertia is mass. Number 2, correct answer is Letter A. You will fly forward. Number 3. The correct answer is B. An unbalanced force. And number 4. Correct answer is C. A school bus because it has highest mass. And for the last item, the correct answer is letter D. To stop our inertia from throwing us forward. And now finally for the ways forward. Our enrichment activity. Learners research additional real-life application of inertia in transportation, sports, and safety devices. And for your assignment, observe your home or community and list 3 situations that demonstrate inertia. Explain how inertia is shown in each situation. See you next lesson! Remember, don't let your mental inertia stop you from learning. Keep moving forward. Thank you for your support. Please like and subscribe to Sir Dom's blog. Goodbye!